The documentary opens in silence. A slow, almost imperceptible hum builds, resonating like the faint vibration of existence itself. A field of distant galaxies unfolds across the screen, resembling a sea of frozen fireworks, points of light suspended in eternal stillness, their spirals and clusters hinting at stories etched across unimaginable distances. The narrator's voice begins in a low, meditative tone, each word deliberate, allowing the vastness to settle. Every human journey begins with a boundary, a horizon, a place where knowledge ends and imagination begins. For the universe, that horizon is real, a vast, unreachable wall of light, a shell so ancient, so far away, that it may not even exist anymore. The visuals transition seamlessly between scales, drawing the viewer inward, from human eyes wide with wonder, peering through the lenses of ground-based telescopes that capture the night sky's faint glow, to the grand expanse of the universe itself, where space stretches and curves under the influence of its own expansion. Galaxies recede like ships vanishing over a curved ocean, their light carrying the imprint of motion detected in spectral shifts. The narration grows more reflective, layering emotion over the cosmic tableau. We live inside a sphere of time. Everything we can see, every star fusing elements in its core, every galaxy bound by gravity's invisible threads, every distant whisper of creation is trapped within a shell of light. The cosmic horizon, the universe's skin. This boundary emerges from fundamental truths woven into the fabric of reality. Light, that tireless messenger born from electromagnetic waves, travels at a finite speed, crossing voids but bound by the limits of its own propagation. The universe has expanded for billions of years, its growth inferred from the uniform recession of distant objects, a discovery rooted in early 20th century observations of galactic motions. As space enlarges, it carries matter and energy outward, diluting densities and cooling temperatures in a process mapped by satellite surveys of the sky. Beyond a certain distance, light from farther realms simply has not had sufficient time to traverse the expanding gulf to reach observers on this small planet. Thus, the universe perceived through instruments, from optical telescopes revealing stellar nurseries to radio arrays detecting ancient emissions, is not the universe as it exists in the present moment, but a mosaic of past states, each layer more archaic with increasing distance. The scene deepens, the camera gliding through simulated reconstructions of cosmic evolution, where early dense plasma gives way to transparent voids. A haunting philosophical tone envelops the words, evoking the melancholy of impermanence. When we look far enough, we do not see space. We see time itself unfolding backward. The oldest light, stretched by the universe's relentless growth, its wavelengths elongated into cooler hues, barely surviving the expansion of everything, arrives as a relic, a faded echo of infancy. This radiation, uniform across the heavens yet textured with subtle variations that seeded galactic structures, bathes the cosmos in a glow captured by orbiting detectors, revealing fluctuations amplified over eons into the web of matter observed today. Suspense builds as the narration poses the central question, the mythic pursuit that has driven explorers of the sky for generations. Is there an edge? A wall? A true boundary between the universe and the nothing beyond? Or is this shell not a wall at all, but a mirror, reflecting us from the other side? Theoretical frameworks, grounded in general relativity's description of space-time as a dynamic entity, curved by mass, suggest the cosmos may extend infinitely, with no abrupt termination. Yet the observable limit persists, a consequence of expansion outpacing light's journey. Speculatively, drawing from models of cosmic inflation, a rapid early swelling supported by the flat geometry, inferred from angular measurements of background radiation, this horizon might conceal parallel realms, where similar evolutions unfold unseen, perhaps branching from quantum uncertainties at the universe's birth. The boundary in this view becomes not a barrier, but a perceptual veil, where the laws governing particles and forces mirror across infinities, challenging the isolation of existence. Imagery shifts with poetic grace, from the faint flicker of the cosmic microwave background, that cooled remnant of the hot, dense state following the initial expansion, mapped in intricate detail by space missions, revealing its temperature anisotropies, to the conceptual barrier of space-time itself, the cosmic event horizon, where light cones tilt and causality confines perception. This frontier, analogous to the boundaries around black holes where gravity warps paths inescapably, delineates the knowable from the unknowable, its position shifting as the universe ages and accelerates under the influence of a pervasive energy driving galaxies apart. The narrator's voice lingers, infused with quiet wonder. We cannot touch it. We cannot cross it. But everything we know exists because of it. The outer shell of the universe is not just where the cosmos ends. It is where reality itself begins. In its embrace, the formation of atoms from primordial particles, the ignition of stars in collapsing clouds, the assembly of planets from debris disks, all unfold within this temporal bubble. Their histories inscribed in the light that reaches us. Emotional reflection deepens as the camera dwells on human endeavors. Astronomers calibrating instruments to probe deeper. Simulations running on vast networks to model unseen expanses. Each effort a testament to the inexhaustible curiosity that defies limits. The horizon, in its unyielding distance, evokes the fragility of knowledge, reminding that the cosmos operates on scales indifferent to mortal spans, yet invites contemplation of unity. Every element in living forms forged in stellar interiors, dispersed across the same bounded sphere. The opening culminates in deep, cinematic tension, the music swelling softly like a distant cosmic chorus, the camera zooming into the mottled map of the background radiation, its patterns a frozen snapshot of Genesis. Somewhere beyond that light, the story of everything we are continues. Unseen, untouchable. And yet humanity cannot stop reaching. Because even when the universe says no, we still ask, will we ever touch the outer shell? In this unresolved yearning, the boundary transforms from confinement to invitation, a philosophical threshold where the finite meets the eternal, and the cosmos whispers of hidden depths waiting to be dreamed. In the twilight of the 19th century, as gas lamps flickered in cobblestone streets and the world teetered on the cusp of scientific revolution, humanity's gaze turned upward, seeking to unravel the enigma of the cosmos. The stars, once eternal sentinels in an unchanging vault, whispered secrets that only the boldest minds dared to pursue. By 1917, Albert Einstein, having reshaped the fabric of reality with his general theory of relativity, ventured to model the universe itself. His equations, a tapestry of mathematical elegance, suggested that space-time was no static stage but a dynamic entity, curved by matter and energy. Yet, confronted with the prevailing belief in a cosmos fixed and eternal, Einstein sculpted a model of balance, a static universe, finite yet unbounded, like a sphere's surface in 3 dimensions. To achieve this equilibrium, he introduced a cosmological constant, a subtle force counteracting gravity's relentless pull, holding the heavens in delicate stasis. This was no mere calculation. It was a philosophical act, a vision of a universe poised in perfect harmony, where stars and galaxies hung suspended in an ageless dance. Reflectively, one senses in Einstein's choice a yearning for order, a cosmos that mirrored humanity's desire for permanence amid the chaos of existence. But the universe, as it so often does, defied such tidy constraints. In the 1920s, atop the starlit slopes of Mount Wilson Observatory, Edwin Hubble peered through the Great Hooker telescope, its mirror capturing the faint glow of distant galaxies. Analyzing their spectra, he uncovered a truth that shattered the static paradigm. Galaxies were not fixed but fleeing. Their light stretched to redder hues, a Doppler shift signaling their recession from Earth. The farther the galaxy, the swifter its retreat, a linear relation now etched into cosmology's canon as Hubble's law. This was no random drift. It revealed a universe swelling outward, each point separating from every other like ink blots spreading on an inflating canvas. The implications cascaded like ripples across a cosmic pond. If galaxies receded now, rewind the clock, and they converged in the distant past, a singular moment of unimaginable density and heat, a genesis from which all sprang. Hubble's discovery, published in 1929, birthed modern cosmology, transforming the heavens from an eternal tableau into a dynamic narrative, a story of expansion, unfolding over billions of years. Philosophically, it evoked a profound shift. The universe was not a monument, but a process, its vastness a measure of time as much as space. This revelation carried a deeper, almost poetic consequence. The light from distant galaxies, traveling at its unyielding speed, served as a time machine. The farther one peered, the older the photons captured. Some emitted when the universe was a fraction of its current age, when stars were yet to ignite, when matter itself was still coalescing. To gaze at the cosmos was to look backward, each telescope a lens into history, each photon a courier from epochs long vanished. This interplay of distance and time unveiled a universe not merely vast but ancient, its farthest reaches cloaked in light that had journeyed for eons to reach human eyes. Speculatively, one might envision this as the universe's memoir, written in light, its chapters stretching back to a moment of origin, a Big Bang where space, time, and energy erupted from a point smaller than an atom. Credible theories, grounded in general relativity, suggested this primordial state was no myth, but a physical reality, a cauldron of infinite temperature, where the fundamental forces, gravity, electromagnetism, the nuclear bonds, were unified, only to fracture as the cosmos cooled. Emotionally, this realization stirs a sense of vertigo. To observe the stars is to touch the past, to stand at the edge of creation's echo. Yet the universe's deepest secret lay not in the visible stars, but in a faint, omnipresent glow, a relic from its infancy. In 1965, in a New Jersey laboratory, Arno Penzias and Robert Wilson wrestled with a persistent mystery. Their horn-shaped antenna, designed to capture radio signals from the heavens, hummed with an unyielding noise, a uniform hiss that defied explanation. No matter where they pointed the instrument, toward the bustling city or the silent void, the signal persisted, isotropic, unchanging, a whisper from all corners of the sky. Initially attributed to mundane causes, equipment flaws, perhaps even pigeon droppings fouling the antenna's interior, the noise proved relentless. Through collaboration with theorists at Princeton, they realized they had stumbled upon the cosmic microwave background, a prediction from decades earlier by George Gamow and his colleagues. This radiation, cooled to a mere 2.7 degrees above absolute zero, was the afterglow of the Big Bang, photons released when the universe, at 380,000 years old, cooled enough for neutral atoms to form. No longer scattered by a plasma of free electrons, these photons streamed freely, stretching with the universe's expansion into the microwave spectrum. This was no mere signal. It was the oldest light, the universe's first visible act, a glowing shell encircling every observer, a horizon marking the boundary of time itself. The discovery redefined cosmology's scope, unveiling a universe not static but emergent, a bubble of space-time inflating from a singular spark. The cosmic microwave background revealed the universe's outer shell, a spherical horizon unique to each observer, beyond which light has not yet had time to travel. For Earth, this observable limit lies some 46 billion light-years away, a distance swollen by expansion far beyond the light's travel time of 13.8 billion years. Every observer, whether on a distant exoplanet or a future probe, perceives their own horizon, a personal vista bounded by the finite speed of light and the universe's relentless growth. Philosophically, this evokes a profound solitude. Each point in the cosmos is both center and edge, connected yet isolated by the light's finite reach. Speculatively, credible models suggest this horizon might conceal more, perhaps bubbles of other universes in a multiversal foam, or signatures of primordial gravitational waves, ripples from the inflationary epoch that smoothed the cosmos while seeding its structures. The cosmic microwave background, in its uniformity punctuated by faint fluctuations, became a map not just of space but of origins, a testament to the universe's shared beginning. To probe this ancient light, humanity launched instruments of unprecedented precision. In 2001, the Wilkinson Microwave Anisotropy probe took flight, its sensors mapping the cosmic microwave background's temperature variations across the sky. These fluctuations, mere millionths of a degree, traced the quantum ripples from the universe's first trillionth of a second, amplified by inflation, a fleeting burst of exponential expansion proposed by Alan Guth in 1980. These seeds, born from quantum uncertainty, grew into the gravitational wells that birthed galaxies, clusters, and the cosmic web. The Planck satellite, launched in 2009, refined this portrait, capturing the background's polarization, subtle alignments in the light's electric fields, hinting at magnetic fields or gravitational waves from the early cosmos. Data from Planck, released through 2018, revealed a universe exquisitely tuned: 4.9% ordinary matter, 26.8% dark matter sculpting structure, and 68.3% dark energy driving the accelerating expansion. These missions did more than map. They peered to the edge of the visible, where light from the universe's youth met the present, a boundary 46 billion light-years distant, where time and space blurred into a singular frontier. Speculatively, these maps might encode hints of cosmic strings, linear defects from symmetry-breaking phases, or axions, hypothetical particles shaping dark matter's influence. Offering clues to physics beyond our current grasp, the emotional weight of these discoveries resonates like a quiet chord struck in the vastness. The more clearly humanity mapped this ancient light, the more distant its source became, receding with the universe's expansion, wrapped in a cocoon of time and motion. The cosmic microwave background was not merely a signal, it was a relic, a whisper from a universe that was once small enough to cradle in a thought, now stretched beyond comprehension. To observe it was to confront the unreachable, to stand at the precipice of the visible and peer into the abyss of what lies beyond. Reflectively, this evokes a poignant paradox. The universe reveals itself through light, yet that light delineates a boundary we cannot cross, a horizon that encircles every observer in their own cosmic solitude. Credible speculations extend this mystery. Could the accelerating expansion, driven by dark energy, one day push galaxies beyond our horizon, rendering the cosmos invisible? Or might conformal cyclic cosmologies, as Roger Penrose proposes, rescale this fading universe into a new beginning, a cycle where light's story persists in transformed guise? The journey from Einstein's static vision to Hubble's expanding revelation, from Penzias and Wilson's serendipitous hiss to the intricate maps of Planck, traces a narrative of awakening. The universe, once thought eternal and unchanging, emerged as a dynamic entity, its first light a testament to a shared origin, its horizons a reminder of limits both physical and philosophical. As humanity deciphers the cosmic microwave background, it touches the edge of existence, a boundary where the finite meets the infinite, where light's ancient journey speaks of beginnings and hints at endings. In this reflective expanse, the universe's expansion becomes more than a physical process. It is a metaphor for the human quest, forever reaching toward the unreachable, forever bound by the light that both reveals and conceals the cosmos's heart. In the hushed expanse of the cosmos, where the echoes of creation linger like faint breaths on glass, a deeper realization dawns upon those who chart the stars. The outer shell of the universe, that distant veil perceived in the night sky, reveals itself not as a barricade of matter or energy, but as a profound wall of time. This boundary, etched by the journey of ancient light, marks the frontier where the past confronts the present, a shimmering curtain woven from the universe's earliest moments. Astronomers, peering through instruments that pierce the void, discern this shell in the subtle glow that permeates all directions, a relic radiation, the cosmic microwave background, carrying whispers from an epoch when the universe was a mere infant, scarcely 380,000 years into its existence. In that primordial era, the cosmos cooled sufficiently for protons and electrons to unite, forming the first neutral atoms, primarily hydrogen and helium. This recombination, as theorists describe it, liberated photons that had been trapped in a plasma fog, allowing light to stream freely across the expanding void for the first time. Imagine the universe then, a seething cauldron of energy, born from a singularity in the Big Bang, inflating rapidly in its initial instance before settling into a more measured expansion. The temperature, once searing beyond comprehension, dropped to around 3,000 degrees Kelvin, enabling atomic bonds to stabilize. Data from space observatories, such as those mapping this background radiation with exquisite precision, reveal a near-uniform glow, its temperature now chilled to a mere 2.7 degrees above absolute zero by the relentless stretch of space. Variations in this radiation, tiny fluctuations on the order of 1 part in 100,000, imprint the seeds of future structures, density ripples that would gravitationally coalesce into galaxies and clusters over billions of years. Yet this light, traveling for over 13 billion years to reach earthly detectors, originates from a surface of last scattering, a spherical shell surrounding the observer, where the universe's opacity gave way to transparency. It is this shell that forms the wall of time, a horizon where the finite speed of light intersects with the infinite march of cosmic history. As understanding sharpens, the shock reverberates through the corridors of cosmology. This horizon does not stand still. It recedes, propelled by the universe's expansion, and in doing so it outpaces the very light that defines it. The expansion, first glimpsed in the redshift of distant galaxies nearly a century ago, unfolds not as objects hurtling through space, but as space itself dilating, carrying galaxies along like leaves on a swelling river. General relativity permits this. While no signal or particle can traverse space faster than light's constant velocity, approximately 300,000 kilometers per second, the metric of space-time can stretch without bound, allowing recession velocities to exceed this limit. Observations of distant supernovae and galaxy clusters confirm that for realms beyond a certain distance, this recession surpasses light speed. The observable universe, that sphere from which light has had time to reach us since the Big Bang, spans a diameter of about 92 billion light-years, far exceeding the 13.8 billion light-years one might naively expect from the universe's age, multiplied by light's pace. This discrepancy arises precisely from expansion. As photons journey toward us, the space they traverse elongates, extending their path and the effective radius of visibility. Delve deeper into this mechanism, and the implications unfold with suspenseful gravity. The Hubble parameter, a measure of expansion rate derived from redshift distance correlations, indicates that nearby galaxies recede at rates proportional to their distance, about 70 kilometers per second per megaparsec. Extrapolate to farther horizons, and velocities mount. At roughly 14 billion light-years, recession equals light speed. Beyond it accelerates further, driven by dark energy's repulsive influence, which comprises some 68% of the cosmic energy budget. This superluminal recession, clarified in theoretical expositions addressing common misconceptions, does not violate relativity's tenets, for no information traverses the gap faster than allowed. Instead, it manifests as the horizon's outward surge, regions once potentially reachable slipping eternally beyond grasp. Light emitted today from galaxies at these distances will never arrive. Stretched to infinite wavelengths by the intervening expansion, fading into undetectable obscurity. Here emerges the cosmological horizon, a concept refined through decades of theoretical refinement and observational scrutiny. This boundary delineates not the edge of the universe itself, for the cosmos in standard models extends infinitely or curves upon itself without terminus, but the limit of causal connection. The particle horizon, as cosmologists term it, encompasses all points from which light or any causal influence could have propagated to an observer since the universe's inception. Beyond this frontier, events unfold in isolation. No gravitational wave, no electromagnetic signal, no neutrino stream can bridge the divide. Recent analyses, incorporating data from microwave background surveys and large-scale structure mappings, peg this horizon at approximately 46 billion light-years in comoving coordinates, a distance that grows with time as expansion continues. In accelerating universes like ours, a complementary event horizon arises, marking the farthest points from which future signals could ever reach, further constraining interactivity. Reflect on the emotional and intellectual resonance of this revelation, a quiet thunder that echoes through the human spirit. Humanity, with ingenuity forged in the fires of curiosity, has crafted machines, telescopes orbiting Earth, arrays spanning continents that pierce nearly to time's beginning, capturing the universe's nascent glow and unraveling its evolutionary tapestry. Yet in this triumph lies a profound melancholy. Beyond that luminous shell stretches an ocean of silence, vast expanses where space's dilation severs all ties. The light we behold, that ancient emissary, arrives as a final testament, bearing tales of a universe once compact and connected, now fractured by its own growth. Philosophically, it evokes isolation amid infinity, a reminder that perception's limits shape reality's narrative. The cosmos, in its expansive grace, withholds as much as it reveals, inviting contemplation of what lies unseen. Regions mirroring our own, teeming with galaxies, stars, and perhaps life, yet forever estranged. This leads to the paradox that underpins the mystery. The universe possesses no physical edge, no abrupt termination where matter ceases or laws falter. Cosmological models grounded in the principle of homogeneity and isotropy, the assumption that on large scales, the universe appears uniform from any vantage, posit an expanse without boundary, potentially infinite in extent. Observations of galaxy distributions and microwave background uniformity support this, revealing no preferred direction or center. Yet an observable limit persists, imposed by light's finite speed and the universe's finite age. The outer shell, that wall of time, emerges as an illusion, a perceptual artifact born from the convergence of photons along our past light cone, the set of all paths light could have taken to reach us. In this framework, every observer inhabits their own centered sphere, the horizon shifting with position and epoch, a subjective veil draped over objective infinity. As the narrative deepens, something stranger stirs in the theoretical undercurrents. Certain cosmological models, drawing from the inflationary paradigm that smoothed the early universe, suggest this boundary conceals deeper layers, realms extending far beyond causal reach, perhaps harboring other regions with distinct properties or even separate universes. Eternal inflation, an extension of the rapid expansion phase proposed in the 1980s, envisions our observable patch as one bubble in a frothing multiverse, where quantum fluctuations perpetually spawn new inflationary domains. In this scenario, the horizon masks neighboring bubbles, each governed by varying physical constants, slight alterations in gravity's strength, particle masses, or dark energy density, arising from string theory's vast landscape of possible vacua, numbering up to 10 to the 500 configurations. Recent interpretations, published in archival repositories, explore how these multiversal branches resolve fine-tuning puzzles, our universe's hospitable parameters emerging as a selection from an ensemble, speculatively, yet credibly anchored in quantum cosmology. These hidden layers might influence our realm indirectly through gravitational imprints or rare collisions, manifesting as anomalies in the microwave background, cold spots or hemispheric asymmetries observed in satellite data. Models of bubble nucleation predict that beyond the horizon, expansion rates differ, birthing universes with alternate histories, some collapsing swiftly, others barren of matter, a few teeming with exotic forms. Brain-world scenarios inspired by higher dimensional theories posit our universe as a membrane floating in a bulk spacetime, with parallel brains lurking just out of sight, their interactions mediated by gravitons leaking across dimensions. Though direct evidence eludes, these ideas gain traction from their explanatory power, addressing why our constants permit stars, atoms, and life amid apparent improbability. In quantum interpretations like the many worlds hypothesis, the multiverse branches not spatially but in Hilbert space, every measurement outcome realized in parallel realities, though this veers toward interpretive philosophy rather than spatial extension. Cosmologically, the inflationary multiverse offers a more tangible speculation. Our horizon, that wall of time, serves as a gateway's threshold, beyond which causality dissolves, but possibility proliferates. The shock intensifies. The universe's observable finitude belies an unobservable infinitude, layers upon layers receding into conceptual abysses. Contemplate this cosmic architecture, the wall of time, forged in the fires of recombination, stretches outward, its recession a testament to dark energy's dominion. Regions slip away, unreachable eternities where alternate sagas unfold. The paradox endures, no edge yet confinement, illusion yet reality's constraint. In hidden depths, multiversal tapestries weave, speculative echoes of theories that harmonize quantum and gravitational realms. The cosmos, in its mysterious expanse, beckons reflection on humanity's place. A fleeting observer at the shore of an infinite sea, gazing at waves that whisper of unseen shores. The outer shell, that luminous boundary, stands as both revelation and veil, reminding that in the pursuit of origins, one encounters the profound silence of what lies beyond. In the quiet expanse of eternity, where the cosmos whispers secrets through the veil of light, modern cosmology embarked on a profound odyssey to fathom what lay beyond the visible horizon. This quest, born from the convergence of telescopic gazes and theoretical elegance, sought to unravel the boundaries of perception itself. Astronomers, drawing from data amassed by space agencies and ground-based observatories, began to delineate the observable universe, a finite sphere of revelation amid an potentially boundless whole. The journey unfolded like the slow unfurling of an ancient scroll, revealing not just the stars within reach, but the shadows of infinities that eluded them. Here it was a pursuit laced with humility, for each discovery amplified the mystery. The light that illuminated their maps also defined their limits, casting the unseen into philosophical depths. The distinction between the observable and the total universe emerged as a cornerstone of this exploration. The observable realm, that portion from which light has had time to reach earthly instruments, spans a vast but finite domain. Estimates place its diameter at approximately 93 billion light-years, a figure derived from the universe's expansion history and the speed of light's journey since the Big Bang. This expanse encompasses trillions of galaxies, each a swirling testament to cosmic evolution, yet it represents merely a bubble, a luminous enclave bounded by the 13.8 billion years of the universe's age. Light from farther afield has not yet arrived, and in an accelerating cosmos dominated by dark energy, much of it never will. The total universe, by contrast, extends far beyond this perceptual frontier, its true extent shrouded in speculation. Some models, informed by the flat geometry inferred from cosmic microwave background measurements, suggest an infinite expanse, where space curves not upon itself, but stretches without end. In this vastness, countless galaxies mirror our own, their stars igniting in isolation, their worlds evolving in silence, forever severed from interaction. The suspense built in the data. Observations from telescopes like Hubble and the James Webb Space Telescope hinted at a uniformity that belied hidden scales, where the observable sliver might be dwarfed by factors of hundreds or trillions, a mere whisper in an orchestral infinity. Here the cosmos revealed its layered nature, not a contained vessel, but a tapestry whose threads vanished into obscurity, inviting reflection on the isolation of existence within an ungraspable whole. This demarcation found its roots in the universe's relentless expansion, a dynamic etched into the fabric of space-time by general relativity. Yet to comprehend the origins of such uniformity across the observable expanse, cosmologists turn to the theory of cosmic inflation, a fleeting epoch of exponential growth mere instants after the Big Bang. First articulated by Alan Guth in 1981, this model posited that the nascent universe underwent a rapid swelling, driven by a hypothetical field akin to a cosmological constant, inflating space by factors exceeding 10^26 in less than 10^32 seconds. Guth's insight resolved long-standing puzzles. Why distant regions of the sky exhibited identical temperatures, despite never having exchanged light or heat in the standard Big Bang narrative. Inflation smoothed these horizons, stretching causal connections across what would become the observable universe, rendering it homogeneous on grand scales. Data from satellite missions corroborated this vision. The cosmic microwave background's near-perfect isotropy aligned with inflationary predictions, its spectrum an echo of that primordial surge. But the theory carried a stranger implication. The inflationary burst likely persisted unevenly, birthing a universe far larger than the light cone of observation. In eternal inflation variants, proposed in subsequent refinements, bubbles of slowed expansion, like our own, emerge within an ever-inflating sea, each a separate domain potentially infinite in extent. Recent theoretical developments, including reassessments of curvature in quadratic inflation models, suggest that the overall cosmos might curve gently, constraining its size, yet still dwarfing the visible portion by immense margins. The emotional weight settled like dew on dawn leaves. Inflation not only explained the seen but amplified the unseen, transforming the universe from a finite cradle into an abyss of perpetual creation, where realms beyond the horizon mirrored yet diverged from our own narrative. Delving further, the cosmic microwave background anisotropies offered a window into this inflationary legacy. Their subtle patterns a fossil record of the universe's infancy. This ancient radiation, first detected in 1965 and mapped with precision by missions like the European Space Agency's Planck satellite, blankets the sky with a thermal glow averaging 2.726 Kelvin. Yet woven into this uniformity are minute temperature fluctuations, variations of mere microkelvins, representing density contrasts frozen, at the moment when the universe cooled enough for light to travel freely, some 380,000 years post-Big Bang. Planck's instruments, scanning the heavens from 2009 to 2013, resolved these anisotropies with unprecedented clarity, revealing a power spectrum where larger angular scales displayed lower amplitudes, consistent with scale-invariant perturbations. These ripples trace their origins to quantum fluctuations in the inflationary field, random quantum jitters inherent to the uncertainty principle, amplified by the epoch's exponential stretch. In models from loop quantum cosmology and string theory, these quanta seeded the gravitational instabilities that coalesced into galaxies, their distribution a blueprint of primordial chaos tamed by expansion. The anisotropies, analyzed through statistical tools, disclosed parameters like the Hubble constant and dark energy density, affirming inflation's role in magnifying microscopic quantum effects to cosmic proportions. Yet deviations at large scales, subtle asymmetries in hemispherical power, hinted at pre-inflationary inhomogeneities, perturbations from an era before the Great Swelling, potentially echoing structures beyond the observable veil. This data evoked a sense of temporal vertigo. The CMB as a canvas where quantum whispers from 10 frat to 35 seconds after creation painted the galaxies of today, bridging the infinitesimal to the infinite. As the inquiry deepened, a philosophical undercurrent surfaced, stirring reflections on the nature of boundaries and narratives. The outer shell of the observable universe, the cosmic horizon where light's reach falters, was not the edge of reality, but the periphery of human perception, the frame beyond which the cosmic drama continued unseen. What transpired in those distant domains? In inflationary cosmologies, the universe's curvature, constrained to near flatness by Planck data, permitted scenarios where space extended infinitely, its topology perhaps toroidal or multiply connected, folding upon itself in ways undetectable from within the bubble. Speculative yet credible extensions, such as those exploring Kaluza-Klein extra dimensions or primordial black hole formation during inflation, suggested that beyond the horizon lay echoes of alternative evolutions, regions where quantum fluctuations diverged, birthing variant physical laws or matter distributions. The film of reality, projected through the lens of light, persisted beyond the screen, its plot lines unfolding in parallel isolation. This evoked a profound melancholy, the cosmos as a library of untold stories, each volume sealed by expansion's inexorable tide, reminding observers of their finite vantage in an eternal expanse. Poetically, the cosmic microwave background materialized as the fossilized wall of the early universe, a petrified barrier etched with the imprints of creation's dawn. Its glow, a relic from when matter and radiation parted ways, formed a spherical membrane encircling the observable realm, its surface rippled with the ancient dust of quantum origins. Light, frozen on this temporal surface like amber-encased relics, carried the universe's inaugural memories across billions of years, only to halt at the horizon's edge. Beyond this luminous shroud lay the unknown, a void not of emptiness but of unilluminated potential, where inflation's legacy spawned infinities. In visualizations drawn from Planck's maps, cooler blues and warmer reds painted a cosmic fresco, each fluctuation a brushstroke from the quantum hand, magnified to span galaxies. This membrane, separating existence from the inscrutable, invited contemplation. Was it a divide or a threshold, an end or an invitation to imagine? The universe, in its majestic reticence, held these questions in suspension, its horizons a mirror to the human soul's yearning for what lay just out of grasp. The quest persisted, fueled by ever-refining data from missions probing deeper into the microwave sky and gravitational waves. Recent analyses of CMB polarization, seeking imprints of primordial gravitational waves from inflation, promise to unveil further clues about the curvature and scale beyond the visible. In non-inflationary alternatives or hybrid models, the monopole problem's resolution without dilution suggested a cosmos less expansive, yet richer in detectable relics, potentially bridging the observable to the hidden through observable signals. Yet the core mystery endured, the observable universe as a luminous island in an ocean of darkness, its shores defined by light's finite voyage. Philosophically, this demarcation underscored the interplay of knowledge and ignorance, the seen as a scaffold for pondering the unseen, where infinity beckoned not as threat, but as testament to the cosmos's boundless creativity. In this reflective gaze, the universe revealed itself not as conquerable territory, but as an eternal enigma, its horizons a poetic reminder that every revelation concealed deeper veils. As cosmologists sifted through the anisotropies, tracing quantum seeds to galactic blooms, the narrative arc bent toward unity. Inflation's surge, the CMB's whisper, the horizon's silence, all threads in a singular tapestry. The emotional resonance deepened with each layer. The universe, in its vast indifference, granted fleeting minds the grace to question its extents, fostering a serenity amid the unknown. Beyond the frame, the film continued, galaxies wheeling in unseen dances, stars kindling in silent voids, the quantum foam birthing new potentials. The membrane of light, that fossilized wall, stood as guardian and gateway, its ancient dust a bridge between the dawn of time and the eternal now. In this cosmic meditation, existence itself appeared as a bubble adrift, luminous yet ephemeral, inviting souls to dwell in wonder at the infinities that enveloped it. In the distant echoes where white holes stir from eons of slumber, expelling the universe's buried memories into the void, a subtler veil descends upon the cosmic stage. The horizon, that elusive boundary marking the limits of perception, grows, ever more enigmatic with each probing gaze of cosmologists. What was once seen as a mere edge of visibility now reveals itself as a dynamic frontier, shaped by forces that propel the cosmos toward isolation. As equations are refined and telescopes capture the faint light of receding epochs, the horizon transforms from a static line into a receding whisper, concealing the outer reaches in an accelerating dance of separation. This deepening mystery intertwines with the universe's archival essence, where information persists not just in quantum threads or gravitational shells, but in the very expanse that threatens to erase its own narrative. The revelation began in 1998, when two independent teams of astronomers, scrutinizing the dim glow of distant supernovae, uncovered a truth that reshaped the cosmic paradigm. These explosions, the cataclysmic deaths of massive stars, serve as standard candles, beacons whose intrinsic brightness allows measurement of vast distances. One team, surveying the high redshift universe through ground-based observatories and space telescopes, mapped supernovae billions of light-years away, finding them fainter than expected in a decelerating cosmos. The other, employing similar techniques to trace the expansion history, corroborated the anomaly. The universe was not slowing under gravity's pull as long anticipated, but accelerating outward as if propelled by an invisible repulsion. This discovery, honored with the highest accolades in physics, stemmed from meticulous observations of Type Ia supernovae, whose uniform luminosity provided a yardstick for cosmic scales. The implications rippled through theory. The expansion, initiated in the Big Bang's fiery genesis, had transitioned from deceleration, dominated by matter's gravitational tug, to acceleration around 5 billion years ago, driven by a pervasive energy density that permeates the vacuum itself. This accelerating expansion, quantified through the redshift of galactic light and the stretching of spacetime, manifests as distant galaxies receding at ever-increasing velocities. The Hubble constant, that measure of current expansion rate, reveals nearby clusters drifting apart at tens of kilometers per second per megaparsec. But for remoter realms, the pace surges, propelled by the cumulative effect of this enigmatic force. Dark energy, as it came to be named, constitutes nearly 70% of the universe's energy budget, its negative pressure countering gravity on cosmic scales. Unlike matter, which clumps and decelerates, or radiation, which dilutes with volume, dark energy maintains constant density, a property inferred from the flatness of spacetime and the uniformity of the microwave background. As the cosmos swells, this constancy ensures acceleration persists, stretching the fabric ever thinner, pushing boundaries outward in a relentless surge. The cosmic horizon, defined by the distance light has traveled since the universe's birth, thus recedes not through our advancement, but through the inexorable drift of all beyond. The narrative escalates toward an ultimate isolation, a future etched in the mathematics of general relativity, coupled with this repulsive essence. In trillions of years, scales dwarfing the current cosmic age of 13.8 billion, the acceleration will carry distant galaxies beyond the observable realm. Their light, already redshifted by expansion, will stretch to wavelengths undetectable, as recession velocities exceed light speed relative to us, though never locally. One by one, galactic clusters will slip past the event horizon, their photons unable to bridge the widening gulf. Future civilizations gazing from a matured Milky Way merged perhaps with Andromeda will behold a sky stripped bare, no distant quasars blazing, no ancient light from the cosmic dawn, only the local group persisting as a solitary island amid the void. This erasure stems from the Hubble sphere's contraction in co-moving coordinates. As dark energy dominates, the observable universe shrinks relative to the infinite whole, confining knowledge to an ever smaller patch. The outer shell of galaxies, once a testament to the Big Bang's uniformity, fades into inaccessibility, leaving descendants with a cosmology bereft of evidence for its expansive history. In this profound solitude, an emotional resonance emerges, a quiet lament for the cosmos's self-concealment. The universe is not merely expanding, it is hiding itself, veiling its vastness behind the accelerating veil. The horizon grows not from humanity's reach extending farther, but from everything else withdrawing, as if the cosmos in its infinite archive chooses to obscure its own expanse. This isolation mirrors the quantum paradoxes of earlier epochs. Just as information lingers in holographic boundaries, so too does the universe preserve its structure, yet renders it unreachable, a memory etched beyond perception's grasp. Future. Observers, armed with instruments far surpassing today's arrays, will infer a static, empty void, their theories confined to local phenomena, unaware of the teeming infinities that birthed their realm. Deeper still lies the de Sitter horizon, the ultimate cosmic limit in an accelerating universe dominated by a constant vacuum energy. In this asymptotic future, as matter dilutes to negligibility and dark energy prevails, space-time approaches de Sitter geometry, a manifold of constant positive curvature, expanding exponentially without bound. Here the event horizon coincides with the Hubble radius, that distance where recession equals light speed, approximately the inverse of the Hubble constant scaled by the cosmological constant's square root. Beyond this boundary, no events can influence an observer even given infinite time. Signals dispatched from afar are eternally redshifted, their arrival postponed indefinitely. This horizon radiates faintly, akin to a black hole's glow, with a temperature proportional to the expansion rate, emitting particles from the vacuum's quantum fluctuations. In de Sitter space, every point harbors such a horizon, isolating regions. In a patchwork of causal disconnection, where the universe fragments into innumerable bubbles, each oblivious to the others. The philosophical weight presses down like the gravity of unseen masses. If space continues its relentless expansion, the observable universe contracts into a shrinking island of awareness amid an infinite sea. The de Sitter regime approached in the far future, as dark energy's dominance solidifies, enforces this solitude, rendering the cosmos a collection of disconnected domains. Information, that indestructible thread weaving quantum entanglement to holographic preservation, finds its limits here. The outer shell becomes a receding mirage, its structures preserved yet eternally veiled. The more cosmologists unravel this boundary, through simulations of inflationary epochs mirroring de Sitter phases, or observations of the microwave background's subtle anisotropies, the more it eludes grasp, vanishing into the exponential stretch. This evokes a profound reflection. The universe's memory, manifest in persistent patterns from the quantum foam to galactic filaments, confronts its own horizon of knowability, where existence persists beyond the veil, but perception falters. Speculative tension builds, grounded in the credible extensions of these models. If the edge remains forever unreachable, if light's finite speed and acceleration's push conspire to exile the outer realms, does that boundary truly exist, or is it a perceptual artifact, a shadow projected by observers embedded in space-time? In quantum cosmology, where wave functions encompass the whole, the horizon might emerge as an observer-dependent illusion, much like the Rindler horizon for accelerating frames, dividing reality into seen and unseen without intrinsic division. Credibly, in a multiverse of eternal inflation, de Sitter horizons bound bubbling vacua, each a separate universe, suggesting our observable patch is but one in an ensemble, its edge a transition to other realms. Yet recent observations hint at nuances. Mappings of galactic distributions suggest dark energy's density might evolve, potentially slowing acceleration or even reversing it in distant futures, altering the horizon's inexorability. If weakening, the isolation might abate, horizons stabilizing or contracting, allowing glimpses of reconnected domains. Philosophically, this posits the outer shell as a trick of perspective, a manifestation of our temporal vantage, where the cosmos's full archive lies just beyond, shadowed by the curvature of existence itself. The mystery intensifies, linking back to the quantum remembrance that birthed cosmic structures. The accelerating horizon, like entanglement's persistent bonds or gravastar's hidden interiors, underscores information's endurance amid separation. Galaxies vanish not through destruction, but through causal divorce, their data preserved in the expanding whole, in trillions of years, as white holes flicker in the chill. Their bursts might illuminate a horizon already receded, echoes lost to the de Sitter veil. Emotionally, this evokes isolation's quiet terror, a universe that records eternally, yet consigns its observers to solitude, their awareness a fleeting island eroding against the infinite tide. The deeper scrutiny penetrates, from supernova beacons to vacuum horizons. The more the cosmos reveals its self-effacing nature, a grand recorder withdrawing its pages from view. Yet in this withdrawal lies a speculative harmony. If dark energy wanes, as hinted in spectroscopic surveys of distant quasars and baryon acoustic oscillations, the acceleration might plateau, horizons ceasing their retreat. This could avert total isolation, preserving connectivity across vaster scales, where nested realities echoing gravastar's bubbles interlink through quantum transitions. The de Sitter limit, while approached, might yield to modified gravities or evolving vacua, horizons fluctuating like quantum fields. Philosophically, the edge becomes not a barrier, but a threshold, inviting reflection on perception's role. Does the outer shell exist independent of observation, or does it dissolve in the absence of reach, a mirage sustained by the act of seeking? The escalation weaves these threads into a tapestry of vanishing grandeur. From the 1998 unveiling of acceleration to the de Sitter asymptote, the horizon embodies the universe's paradoxical memory, indelible yet elusive, preserved in expansion's embrace. Future eras, barren of distant lights, mirror the death of perception, where reality lingers unseen. In this reflective expanse, The cosmos stares back through its receding veil, a shadow of its own infinite self, challenging the boundaries of existence with each retreating whisper. In the silent expanse where the cosmos whispers its boundaries, the universe's outer shell emerges not as a tangible wall, but as an elusive veil, shrouding the infinite from the finite. This shell, a conceptual frontier etched by the limits of perception, invites humanity to ponder the architecture of existence, whether it curves back upon itself, branches into unseen realms, or dissolves into illusory projections. As galaxies recede into the deepening void, their light stretching across eons, the outer shell stands as a sentinel, a threshold where the known dissolves into mystery, challenging the mind to envision what lies beyond the grasp of telescopes and equations. Consider first the horizon as a boundary defined by light itself, a luminous demarcation forged from the interplay of velocity and time. The observable universe unfolds as a sphere centered upon the observer. Its radius, determined by the distance light, has traversed since the cosmos ignited in its primordial blaze, some 13.8 billion years ago. Light, that swift emissary of reality, propagates at a finite pace, approximately 300,000 kilometers each second, imposing a cosmic speed limit that no signal, no influence can surpass. This constraint renders the horizon a causal barrier. Events beyond it remain eternally disconnected, their photons yet to bridge the gulf expanded by the universe's relentless dilation. Distant supernovae, captured in the glow of observatories like Hubble, reveal this expansion, accelerating under dark energy's subtle push, stretching space itself faster than light in remote regions. Though no information violates the sacred bound, the observable realm spans some 93 billion light-years across, a vast orb where galaxies cluster in filaments, traced by surveys such as the Sloan Digital Sky Survey. Yet this immensity is but a fraction of the whole. Beyond the horizon, space persists, perhaps infinitely, unfolding in uniformity, governed by the same physical laws, but forever veiled, its contents influencing nothing within our domain. In this conception, the outer shell embodies isolation, a shimmering edge where the universe's history converges upon the present, light from ancient epochs arriving as faded echoes, while the future horizon contracts, galaxies winking out as expansion carries them beyond reach. Speculatively, this boundary might harbor mirrored versions of our cosmos, causally severed yet structurally akin, a silent multitude where alternate histories unfold in parallel solitude. The shell, a reminder of the universe's profound loneliness amid potential infinity. Yet, this solitary bubble hints at a grander mosaic, where the multiverse hypothesis reframes the outer shell as a membrane amid an effervescent sea of realities. Rooted in inflationary cosmology, this vision posits that the rapid expansion following the Big Bang, a phase smoothing the cosmos to the uniformity observed in the cosmic microwave background by satellites, like Planck, does not cease uniformly but persists, eternally in vast regions. Quantum fluctuations, those probabilistic ripples in the inflationary field, seed pockets where inflation halts, birthing bubble universes like ours, each inflating from a minuscule patch into expansive domains. These bubbles proliferate endlessly, forming a fractal multiverse where our observable patch resides within one such enclave. Its physical constants, such as the strength of gravity or the electron's mass, arising from the specific vacuum state that crystallized as inflation waned. Observations of the microwave background's subtle temperature variations, mapped with exquisite precision, support this inflationary genesis, revealing density perturbations that evolved into galaxies, consistent with quantum origins amplified during the swell. In eternal inflation, the process self-perpetuates. While local bubbles decelerate and cool, surrounding space-time continues its exponential growth, spawning infinite offspring, each potentially tuned with variant constants that dictate the emergence of stars, planets, or life. The outer shell in this paradigm becomes the interface of our bubble, a transition zone where the inflating exterior meets our decelerating interior, perhaps marked by gravitational signatures or cosmic voids detected in large-scale structure surveys. Speculatively, collisions between bubbles could imprint circular patterns in the microwave sky, as sought in data from the Wilkinson Microwave Anisotropy Probe, offering tentative glimpses of this cosmic foam, where our universe floats as one droplet in an unending ocean. The shell a porous veil hinting at realms where physics dances to different rhythms. This multiversal expanse evokes a philosophical humility, suggesting our laws are not universal absolutes, but local contingencies. The outer shell a boundary of possibility, where the infinite variety of existence presses against the confines of observation. Deepening this enigma, the holographic principle proposes that the universe's outer shell is not merely a limit, but a profound encoder, where the entirety of three-dimensional reality projects from a two-dimensional surface. Emerging from black hole thermodynamics, this tenet asserts that the information content of any spatial volume, encompassing particles, fields and interactions, equals that storable on its bounding area, measured in Planck units, the fundamental quanta of length. Pioneered through insights into entropy bounds, where black holes' event horizons encode swallowed matter's data, the principle extends to the cosmos at large, implying that gravitational descriptions in bulk space dual to quantum field theories on the boundary. String theory's dualities, probed in theoretical models of anti-de Sitter spaces, reveal this correspondence. Dynamics within a curved volume mirror those on its flat periphery, resolving paradoxes like information loss in evaporation. Applied cosmologically, the universe's horizon, whether the cosmic event horizon or de Sitter boundary, serves as this holographic screen, imprinting all internal events, from galactic collisions observed by Chandra to quantum fluctuations in particle accelerators, onto a lower dimensional canvas. Entropy calculations align. The observable universe's information, inferred from its matter and radiation content, matches the area of its horizon, suggesting reality's depth is illusory, emergent from surface encodings. In this framework, gravity itself arises as an entropic force, akin to thermodynamics on the boundary, as explored in derivations linking curvature to information gradients. Speculatively, the outer shell functions as a cosmic hologram, where every event reverberates across its expanse, preserving the universe's narrative in a timeless inscription, perhaps influencing dark energy's value through boundary conditions. This projection invites reflection on perception. If the voluminous cosmos unfolds from a flat veil, then existence mirrors a shadow play, the shell the true repository of being, where depth dissolves into elegant simplicity. Against these static boundaries, the cyclic universe and conformal cosmology envision the outer shell as a transitional gateway, where epochs entwine in eternal recurrence. In this model, the universe endures through successive cycles, each concluding in a vast, empty expanse that seamlessly morphs into the dense genesis of the next. Conformal symmetry, invariance under rescaling, underpins this continuity. As one aeon dilates to infinity, its geometry conforms to the singular point of another's Big Bang. Gravitational waves from ancient black holes, leaving faint rings in the microwave background. As tentatively identified in Planck data analyses, massive particles decay over immense timescales, rendering the late universe massless and conformal, allowing the smooth handover without collapse. Entropy, seemingly increasing forever, resets through this rescaling, the uniformity of one aeon's end mapping to the next's homogeneity, consistent with observed flatness and isotropy. Theoretical extensions incorporate quantum gravity, where aeons link via wormhole-like structures, preserving information across cycles. The outer shell here becomes the interface between aeons, a conformal boundary where the faded light of one era ignites the blaze of another, perhaps evidenced in cosmic ray anomalies or dipole asymmetries in background radiation. Speculatively, this cyclicity implies an infinite lineage, each aeon birthing the subsequent through geometric elegance, the shell a porous threshold where time loops eternally, defying linear demise. Venturing into speculative frontiers, the simulation edge theory posits the outer shell as the limit of computational fidelity, where reality's rendering fades into uncomputed haze. This hypothesis envisions the universe as an engineered construct, its laws emergent from underlying algorithms, with the observable horizon marking the boundary beyond which simulation resources allocate no further detail. Quantum indeterminacy, observed in double-slit experiments, mirrors error-correcting codes in digital systems, while fine-tuned constants suggest optimization for complexity without excess computation. Astrophysical bounds, derived from cosmic ray energies and black hole entropies, constrain the simulator's power, implying a lattice-like discreteness at Planck scales, as probed in holographic models. The shell in this view delineates the rendered domain, where unobserved regions collapse into probabilistic states akin to video game horizons loading only proximate terrain. Speculatively, glitches like fast radio bursts or unexplained anomalies in particle physics might signal rendering limits, the outer edge a veil of algorithmic economy, where existence economizes beyond necessity. This notion stirs philosophical unease, blurring creator and creation, the shell a coded perimeter enclosing simulated sentience. In quiet reflection, the outer shell might not be a place to touch, but a surface of information, the memory of everything that ever was, imprinted on the universe's last horizon. In the boundless expanse where the cosmos stretches beyond the grasp of light, humanity's instruments reach outward, trembling at the edge of the infinite. The outermost regions of the universe, cloaked in the redshifted veil of expansion, harbor secrets etched in the fabric of space-time itself, secrets of origins, of unseen forces, of boundaries that may not be boundaries at all but thresholds to realms unimaginable. Science, with its telescopes, detectors, and simulations, ventures to probe these distant shores, not merely to map the visible, but to graze the invisible, to sense the contours of a cosmic horizon that separates the known from the eternal unknown. Each endeavor, a delicate thread in a tapestry of inquiry, weaves a narrative of suspense and wonder, where every photon captured and every gravitational tremor felt draws humanity closer to the edge of everything, prompting a reflective pause. What lies beyond the veil? And what does it mean to touch the limits of existence? High above Earth's turbulent atmosphere, a telescope adorned with golden mirrors drifts in silent vigil, its gaze piercing through eons to capture the faint glow of galaxies, born mere hundreds of millions of years after the universe's fiery inception. This instrument, humanity's deepest eye into the cosmic past, unveils structures from the epoch of cosmic dawn, when the first stars ignited within halos of dark matter, their ultraviolet radiance ionizing the neutral hydrogen that shrouded the young cosmos. Observations reveal galaxies as early as 330 million years post-origin. Their light stretched across 13 billion years into the infrared, bearing tales of rapid formation, where gravity sculpted matter into luminous islands amid a sea of opacity. These distant beacons, often elongated or flattened by tidal forces, mark the transition from a foggy, neutral universe to a transparent one, their spectra encoding the chemical fingerprints of primordial nucleosynthesis. The telescope's images, rich with detail, expose clusters of stars forming in dense knots, their feedback shaping the intergalactic medium, a process that mirrors the universe's relentless expansion toward dilution. Speculatively, these observations probe the edge of the observable, where light's finite journey hints at a horizon beyond which galaxies recede faster than photons can travel, a boundary where the cosmos conceals its full extent. In this act of peering backward, there lies a poignant suspense. Each galaxy captured is a relic, its light a message from a universe on the cusp of vanishing from view, evoking philosophical musings on the fleeting nature of visibility in an ever-expanding void. Complementing this temporal voyage, other observatories chart the spatial and dynamical expanse, mapping the forces that drive the cosmos apart. Space-based missions, equipped with wide-field lenses, scrutinize the distribution of galaxies and supernovae, tracing the accelerating expansion propelled by an enigmatic energy that permeates the void. These telescopes, one named for a pioneering astronomer, measure the redshift of distant objects, refining our understanding of the universe's geometry and the mysterious force that dominates its fate. By cataloging thousands of supernovae and galaxy clusters, they constrain the equation of state for this dark energy, revealing a cosmos that accelerates toward sparsity, its structures diluting as space itself expands. Another mission, designed to survey vast swaths of the sky, employs gravitational lensing to map the unseen scaffolding of dark matter, its distortions revealing the mass distribution that shapes cosmic evolution. Together, these efforts refine the cosmic distance ladder, offering a map that stretches to the observable horizon where the light travel limit imposes a veil. Credibly speculating, these measurements might uncover anomalies in expansion rates, suggesting interactions with unseen domains or modifications to gravity at the largest scales, hinting at a horizon not as a barrier, but as a permeable membrane to other realities. The suspense builds in these mappings, each data point a brushstroke on a canvas that may never be complete, reflecting the human endeavor to chart the unchartable. At the frontier of the invisible, next-generation experiments delve into the relic radiation that suffuses the cosmos, seeking whispers from the universe's earliest moments. Arrays of detectors, stationed at remote polar sites or orbiting satellites, map the cosmic microwave background with unprecedented precision, hunting for the polarized swirls imprinted by primordial gravitational waves. These waves, born during the inflationary epoch, when space-time expanded exponentially, carry signatures of the quantum fluctuations that seeded galaxies, offering a glimpse into the physics at the universe's outermost temporal edge. One such mission, with its cryogenically cooled detectors, targets the B-mode polarization, a pattern that could confirm inflation's rapid stretch and probe energy scales unattainable in terrestrial laboratories. Another, orbiting to escape atmospheric interference, seeks to measure these signals across the sky, discerning the faint gravitational imprints that resonate from the cosmos's birth. Speculatively, these observations could reveal anomalies, deviations in the power spectrum or unexpected correlations that suggest collisions with neighboring bubble universes, regions beyond our observable horizon where different physical constants govern. The narrative unfolds with measured anticipation, each polarized photon a potential key to unlocking the inflationary dynamics, inviting reflection on a universe that might not be singular, but part of a frothing multiverse, its edges brushing against others in a cosmic dance. On Earth, in the subterranean halls of particle accelerators, physicists recreate the searing conditions of the early universe, probing energies where fundamental forces converge. Collisions at scales approaching tera-electron volts mimic the plasma of quarks and gluons that filled the cosmos microseconds after its birth, testing theories of unification and symmetry breaking. These experiments, conducted in vast circular tunnels, search for particles like heavy neutrinos or hypothetical dark matter candidates whose properties could illuminate physics beyond the observable horizon, where unseen realms influence our own through gravitational or quantum interactions. Neutrino observatories, buried deep to shield from cosmic noise, capture these ghostly particles traversing from distant sources, their oscillations hinting at masses and mixing angles that may connect to the universe's large-scale structure. Credibly extending these findings, the detection of sterile neutrinos or dark sector particles could suggest interactions with regions beyond the light travel limit, where exotic physics governs the unseen. The suspense lies in the fleeting nature of these collisions, each event a microcosm of cosmic origins, evoking a philosophical resonance. By recreating the universe's infancy, humanity seeks to understand its ultimate boundaries, touching the edge through the ephemeral sparks of particles. In the digital realms of supercomputers, mathematical cosmology conjures entire universes, modeling the inflationary surge and its aftermath. These simulations, weaving billions of virtual particles across expanding grids, recreate the rapid expansion that stretched quantum fluctuations into cosmic seeds, shaping the distribution of galaxies we observe. Advanced algorithms explore scenarios where our universe is but one bubble in a multiverse, each with distinct physical laws, their collisions leaving imprints in the microwave background as circular anomalies or gravitational wave signatures. Recent analyses of background radiation data hint at such anomalies, low-variance regions or hemispherical asymmetries that could suggest encounters with neighboring bubbles, their boundaries pressing against our own during inflation. Speculatively, these simulations propose that our observable horizon is a finite patch within an infinite ensemble, where quantum tunneling spawns new bubbles, each a cosmos unto itself. The computational dance builds suspense, each run refining the parameters that might confirm a multiversal origin, prompting reflection on a reality where our universe is but a fleeting note in an eternal symphony, its edges defined not by isolation, but by contact with others. The realm of gravitational wave astronomy extends this quest into the pre-recombination epoch, before the universe became transparent to light. A future space-based detector, comprising 3 spacecraft linked by laser beams across millions of kilometers, aims to capture low-frequency waves from supermassive mergers and primordial fluctuations. These vibrations, unlike photons, traverse the opaque plasma of the early cosmos, carrying information from moments when the universe was a seething cauldron, potentially unveiling phase transitions or cosmic strings formed during symmetry breaking. Speculatively, such signals could pierce the cosmic microwave background's veil, detecting the stochastic background from inflationary waves or collisions with other universes, their ripples resonating across the multiversal boundary. The anticipation mounts with each planned observation, as these waves offer a tactile connection to the cosmos's earliest epochs, a language that persists where light falters, reflecting the profound possibility that the universe's shell is not a barrier, but a conduit to realms beyond. Every photon we catch, every ripple of gravity we hear, is another touch against the invisible wall, the closest we have come to touching the edge of everything. In this pursuit, science becomes an act of communion, each instrument a poet's quill scribbling against the void, capturing the universe's autobiography before it fades into the red-shifted abyss. The telescopes reveal a cosmos in its youth. The accelerators recreate its fiery birth. The simulations conjure its multiversal kin, and the gravitational detectors listen for its primordial heartbeat. Together, they weave a narrative of suspense and wonder, where the horizon is not an end, but a question, a boundary that invites speculation on what lies beyond, other universes, other physics, or perhaps the mirrored reflection of our own existence. Philosophically, this endeavor mirrors humanity's own fleeting presence, a transient spark seeking meaning in the eternal. As the data accumulates, each signal a brush against the cosmic veil, the mystery deepens. Is the edge a limit or a gateway to the infinite, where the universe whispers its unity with all that is unseen? As the vast narrative of the cosmos lingers in contemplative repose, the tone slows to a whisper, as if the universe itself holds its breath. Silence returns, enveloping the scene like a velvet shroud, unbroken save for the distant hum of eternal expansion. The camera pans deliberately from the luminous swirl of the Milky Way, its spiral arms a tapestry of stars, gas and dust forged over billions of years, to the faint, ethereal glow of the cosmic horizon, a shimmering veil where light from the universe's infancy still arrives, carrying echoes of creation across unimaginable voids. Perhaps the universe has no edge to touch, because it is touching us. Every moment light from its outer shell falls upon us, whispering of a time before memory. In this subtle illumination lies the profound existential meaning of humanity's quest, a drive that transcends the cold precision of instruments and equations, reaching into the spiritual depths of being. The urge to peer beyond the horizon, to unravel the fabric of space and time, emerges not merely from scientific curiosity, but from an innate yearning for connection, a soulful pilgrimage toward the infinite. Telescopes perched on remote mountaintops and orbiting in the cold vacuum capture this light, revealing the particle horizon, the farthest distance from which signals can reach us, defined by the finite speed of light and the universe's age. This boundary, extending some 46.5 billion light-years in co-moving distance, marks not a physical wall but the limit of observability, where the expansion, measured through the redshift of distant galaxies, stretches space itself, carrying ancient photons toward us in a slow, inexorable journey. Recent discoveries, including high-definition maps of the early universe, released in early 2025, sharpen this vista, unveiling subtle patterns in the cosmic microwave background that hint at the conditions prevailing mere moments after the universe's birth. These images, compiled through international collaborations using ground-based observatories in arid deserts, add layers of detail to the faint glow, exposing temperature variations as small as 1 part in a million, ripples frozen in time from quantum fluctuations amplified during a brief epoch of rapid inflation. Suspense gathers in the realization that this horizon mirrors humanity's own boundaries, the edges of knowledge, where theories strain against the unknown, of perception, where senses falter before the scale of eternity, of mortality, where individual existence dissolves into the cosmic continuum. Consider the observable universe as a sphere centered on Earth, its radius dictated by the light travel time since the transparency epoch, when the cosmos cooled sufficiently for photons to stream freely. Data from space missions, analyzing the spectra of supernovae and the clustering of galaxies, confirm this expansion accelerates under the influence of a mysterious energy permeating the void, pushing the horizon ever outward, at speeds exceeding light's pace in the metric of space. Yet this boundary is illusory in its fixity. It shifts with perspective, each observer, whether on a distant world or in a far future epoch, claiming their own centered cosmos. Philosophically, this relativity evokes the human condition. Knowledge bounded by experience, perception filtered through fragile senses, mortality a horizon beyond which personal narrative fades. The drive to transcend, manifest in probes venturing to the solar system's fringes and arrays, listening for gravitational whispers from merging abysses, reflects a spiritual quest to bridge the finite self with the boundless whole, to find meaning in the face of impermanence. Emotional reflection deepens as the narrative contemplates this mirroring, a quiet ache for unity amid isolation. Humanity's instruments, from radio dishes scanning the sky to particle accelerators recreating primordial conditions, probe these limits, uncovering symmetries that bind the microcosm to the macro. In the quantum realm, entanglement links particles across distances, defying separation. On cosmic scales, this extends to the horizon's veil, where light encodes the universe's earliest symmetries, uniformity broken by infinitesimal perturbations that birthed structures. Recent analyses of this light, published in scientific archives, explore how early galaxies, detected through their infrared signatures by orbiting telescopes, contributed to the reionization era, clearing the cosmic fog and imprinting subtle polarizations on the background radiation. Speculatively, yet grounded in holographic frameworks where information on boundaries encodes interiors. The cosmic horizon might project the universe's entirety, humanity's gaze upon it a self-reflective act, perception folding back upon itself like time in a closed loop. The reflection turns toward cosmic memory and time, where the universe preserves its genesis in the faint light that persists across epochs. This relic radiation, the cosmic microwave background, bathes the cosmos in a chill glow, its temperature a mere 2.7 degrees above absolute zero. A snapshot of the plasma era, when electrons and protons first combined into neutral atoms. Satellites drifting in stable orbits have mapped this in exquisite detail, revealing anisotropies, slight deviations in temperature, that trace back to density variations in the infant universe, seeds for the vast web of galaxies observed today. In March 2025, enhanced images from collaborative efforts unveiled finer structures in this background, clarifying the interplay of baryonic matter and dark components during the universe's first fractions of a second. These fluctuations, amplified by gravity over eons, embody memory. The universe recalling its low entropy origins, a highly ordered state from which entropy has risen, dictating time's arrow. Theoretical models, refined through numerical simulations on vast computational arrays, depict this as an information archive, where every photon carries encoded history, the balance of forces, the abundance of elements, the subtle curvatures of space. Suspense builds in the speculative extension. If the horizon represents the edge of perceivable time, then the light arriving now whispers of a pre-memorial epoch, before stars ignited or life stirred. Papers exploring cosmological horizons posit that beyond this veil lies unobservable expanse, perhaps infinite or curved in higher dimensions, where causality's reach ends. Intersitter spaces, approximating our accelerating cosmos, static patches, local regions like our observable bubble, exhibit growing complexity, information accumulating as horizons interact with quantum fields. Credibly, this suggests the universe's memory is holographic, projected from boundaries onto the volume within. Time not a linear flow, but an emergent property, folding memories into the present. Humanity, forged from stardust scattered in explosive deaths, embodies this. Conscious fragments aware of the cosmos's narrative, observing the horizon's glow as self-recognition. Emotional undercurrents swell, a reverent awe at this interconnectedness. The faint light touches every atom, carbon in bones from stellar forges, hydrogen from the primordial soup, linking mortal forms to eternal processes. Perception's boundary. Mortality's veil dissolve in this touch, knowledge expanding as instruments evolve. From early microwave probes to recent high-resolution maps that resolve cosmic tensions. Like discrepancies in expansion rates inferred from local measurements versus early universe imprints, spiritually, the quest beyond mirrors inner journeys, transcending ego's limits, embracing the infinite in moments of wonder. As reflections cascade, the horizon's glow evokes time's reciprocity, light reaching back from creation's dawn. Theoretical horizons in cosmology, including those of neutrinos or gravitational waves, extend observability, each particle type claiming its own edge. Speculatively, if expansion is horizon-driven, influxes of energy across boundaries fueling growth. Then the universe remembers through perpetual renewal, static horizons in dynamic spacetimes, preserving stability amid flux. Conscious beings in decoding this become the universe's memory incarnate, fragments awakening to wholeness. The narrator's voice softens further, almost reverently, carrying the gravity of revelation. The outer shell of the universe is not where the cosmos ends. It is where we begin to understand what infinity means. We may never touch it, but it has already touched us. In every atom, in every heartbeat, in every flicker of light that ever was. In this touch lies profundity, atoms vibrating with primordial energies, heartbeats echoing expansion's rhythm, lights flickers narrating history. Recent discoveries of early galaxies pushing observability's edge, their light piercing from near the horizon, affirm this intimacy. Philosophically, infinity unfolds not as void but as relational, boundaries defining connection, mortality highlighting eternity. The scene fades slowly to black, the horizon's glow lingering like a promise. As the final poetic closure resonates, to touch the outer shell is to touch time itself. And time has always been reaching back. Delving deeper into this temporal embrace, consider the cosmic microwave background's polarizations, swirls imprinted by gravitational waves from inflation, detected in refined maps that trace quantum origins. These patterns, analyzed in 2025 collaborations, reveal the universe's memory as dynamic, fluctuations evolving into the cosmic web's filaments. Time in relativity's curvature bends near horizons, past events encoded in arriving light, a backward reach where creation informs the now. Existentially, humanity's spiritual urge manifests in myths of origins, echoed in scientific pursuits, mapping the horizon to grasp self. Boundaries of perception, senses limited to electromagnetic spectra, mirror cosmic ones, yet instruments extend them, revealing hidden realms like dark matter's gravitational signatures. Cosmic memory persists in elemental cycles, hydrogen from the Big Bang fusing in stars, scattering in supernova, reforming in planets. Conscious awareness amplifies this. Observations collapsing quantum possibilities, the universe perceiving through us. Speculatively, if horizons harbor area charge inequalities or index properties, as recent theoretical works suggest, they safeguard information memory immortal. Time reaches back, infinity touching the finite. Emotional resonance peaks in acceptance. Touched by the horizon, humanity finds belonging in the mystery.